Projectiles type 4b clearing a wall. So in this question here we have a particle is projected from a ground with a velocity of 50.9 meters per second at an angle of tan inverse of 5/12 to the horizontal, and on its upward path it just passes over a wall 14.7 meters high. So if we were to sketch the projectile path, we have our initial velocity, which is 50.96 meters per second. And we have our projectile path. So we're given a wall which is 14.7 meters high, and we're told on its upward path it just passes over the wall. So that means the wall is somewhere around here in its upward path, and it's just passing over that wall. So that wall is 14.7 meters high. So that would be your SY. Now we're told it also passes over a second wall 18.37 meters high, and we have to show that the second wall must not be less than 23.52 meters and not more than 70.56 meters from the first wall. So basically what that means is that there are two positions that the second wall can have. So if I use a different colour just to draw the second wall, and of course if there are two places that the height can be of the wall can be 18.375 meters high, that basically means that it should be on the upward and on the downward path. So there's one position, and here would be a second position where SY would be 18.375 meters. So what we're looking for then are the two possible positions. So the distance from the first wall and then the distance from the second position of the wall. So this would be position 1, if I was to call it D1 and D2. These are our two possible positions that these can have. Now we're also given the angle, so let me call the angle alpha here. And the angle alpha, if we work it out over here to the side, is given to me as tan inverse of 5/12. So of course that means that tan alpha equals 5/12. So if I complete my right angle triangle, I have opposite over adjacent, and it's one of our favourite Pythagorean triples. So 5, 12 and 13. And of course you can use Pythagoras if you can't remember that one off by heart. But obviously 3, 4, 5 is our other commonly used Pythagorean triple. And from that then I can see sine alpha is the opposite over the hypotenuse. And cos alpha is equal to 12/13. So our adjacent over hypotenuse. Okay, so we have our diagram drawn out showing us what's going on. We have our angles worked out. So in order for us to prove these two positions must not be less than 23.52 meters and not more than 70.56 meters from the wall, we're going to have to figure out how we're going to do that. So of course we start the same way as we always do, by filling out our table. And we're going to work out our U, A, V, S and T in both the X and the Y direction. So again, you're going to pause the video and see can you complete the table, and then check in with the video and see have you completed the table properly. So we have U cos alpha. If I just do it down here to the right first, well, if we have U is 50.96 and cos alpha is equal to 12/13, well then U cos alpha gives us 47.04. So if I fill that into my table, U in the X direction is 47.04 meters per second. And if I look at u sine alpha, so our velocity in the y direction, well then this is 50.96 times sine alpha, which is 5 over 13. And therefore that gives us a velocity of 19.6 meters per second. So in other words, u in the y direction is 19.6 meters per second. So A, as always, in the horizontal direction is 0 because we're moving on a horizontal plane. Our initial velocity is in the upward direction, therefore g is down in the opposite direction, so we assign a negative value to g. So again, you can put in g, or you can use 9.8. I'm not trying to prove anything in this case in terms of g, so I'm going to use 9.8. We know that v is equal to u plus at. So v in the x direction is u plus at, so it's just going to be 47.04. And v in the y direction is 19.6 minus 9.8t. S we know is ut plus a half at squared. So of course in the x direction that's simply going to be 47.04t. And in the y direction it's 19.6t minus a half of 9.8 is 4.9t squared. And of course time is in terms of t. Okay, so we have our table made out, we have our diagram drawn, and we have all of our angles worked out. So if we take a closer look at the diagram in terms of how we're going to show that the second wall must not be less than 23.52 metres and not more than 70.56 metres from the first wall. Well, basically we know that the first wall is 14.7 metres high. So therefore we know that we can work out the time at which the particle is just clearing the wall. Now, if we can work out the time at which it just clears the wall, then if you look at the diagram, what that's going to allow me to do is it's going to allow me to work out the distance from the initial position of the particle to where it just clears the wall. In other words, I can get the time at which it's just clearing the wall. So I can work out what S of x is. So we're going to start on the next page by looking at Sy is equal to 14.7 metres, which is the just clearing the wall. And I want to know at what time does that happen. So Sy is equal to 19.6t minus 4.9t squared. And if I let that equal 14.7, well, I'm going to end up with a quadratic equation. So I have 4.9t squared minus 19.6t plus 14.7 equals 0. Now, if I divide across by 4.9, I end up with a lovely quadratic, t squared minus 4t plus 3. If you don't spot that, of course, you can use the minus b formula, no problem. But here I can see that the two numbers that are going to multiply to give me 3 and add to give me minus 4 will be minus 3 and minus 1. So I'm just going to factorise out my quadratic. Or you can use your minus b formula, or whichever way you want to solve your quadratics. So therefore t minus 3 is also common, and I have t minus 1 is equal to 0. And therefore if I let both of those factors equal to 0, I get t is equal to 3 or t is equal to 1 second. So in other words, on the upward path, it'll clear the wall. Sorry, that should say on the way up. And then it'll come back down over a height of 14.7 on the way down. So the time that we're interested in is on the way up. Because if I go back to the question, I can have underlined here, on its upward path, it just passes over a wall of 14.7 metres high. So if I was to look, 14.7 metres high is also over the far side to the right. I don't want to draw on the diagram because I don't want to confuse you with the green walls. But that would occur at 3 seconds. So what we want to know now is what is Sx? What's the distance from the initial firing position of the particle into the air to the base of that wall that's 14.7 metres high? Okay, so we look at S of x when t is equal to 1 second. And therefore we have S of x is equal to 47.04 t. So very easy. If I sub in for 1, I obviously end up with 47.04 meters. Okay, so that's the distance to the base of the wall. So now, if I look at the second wall, so again I go back to the question, we're told the second wall that it has to pass over, if I highlight, is 18.375 meters. So if I know the time at which this occurs, well then I can work out again the distance from the starting point here to the foot of the green wall. So in other words, the wall that's 18.375 meters high. And that distance would be Sx plus the distance between the wall that's 14.7 meters high and the wall that's 18.37 meters high. Okay, so let's have a look at that. So we're going to find the time it takes to clear the wall when the wall is 18.37 meters high. So when it just clears the second wall, so again we're going to take our equation for Sy, which is 19.6t minus 4.9t squared. And if I let that equal 18.375, again I'm going to end up with another quadratic, 4.9t squared minus 19.t plus 18.375. And again, if I divide across by 4.9, I'll end up with a quadratic that's a bit messy, but again, if I divide across by 4.9t squared, you can see that still works out to be quite a nice quadratic. Again, you might just go straight to your minus b formula. But what we end up with here is 15 over 4. And I can, of course, multiply that back across by 4. And now I multiply across back by 4. I end up with 4 times 15, which is 60. And the factors of 60 that multiply to give me 60 are 6 and 10. And if I take minus 6 and minus 10, they'll multiply to give me plus 60 and add to give me minus 16. So when I put those back in, I can factorise, or as I said, you can use the minus b formula, nothing wrong with that. And I can factorise out 2t as being common, leaving me with 2t minus 3. And if I take out minus 5 as being common, I'm left with 2t minus 3. And then 2t minus 3 is also common, leaving me with 2t minus 5 is equal to 0. So if both of those factors multiply to give me 0, that means that one or both must be equal to 0. So that gives me 2t minus 3 equals 0, or 2t minus 5 equals 0, and therefore t is equal to 3 over 2, or t is equal to 5 over 2 seconds. And of course you can see that there are 2 times, because again we're passing on the way up and on the way down. So in other words, there are 2 times t1, let's call it, and t2. So again, if I go back to my diagram, 3 over 2 seconds would be the time that it takes to clear this one. And t2 would be when it's 5 over 2 seconds. So therefore, what we can see now is that if I sub in the time 1, I'm going to get the distance from the starting position to the first position of the green wall, and from the starting position to the second position of the green wall. And then by subtracting S of x from each of those values, that will give me the distance between the red and the green wall for the both positions. Okay, so let's see that then. So we've worked out our 2 times. So now I'm going to see what is x, S of x. So S of x is equal to S of x when t1 is equal to 3 over 2 seconds. So we know that S of x is equal to 47.04 t. So therefore the distance to the first position of the wall from starting position is 70.56 meters, and the distance from the starting position when the time is 5 over 2 seconds then is 47.04 times 5 over 2, which gives me a distance from the starting position to the second wall to be 117.6 meters. And therefore we say, hence, let me draw a diagram. Well, I have my red wall. And I know the distance is 47.04. So that's that distance. I have my second wall. And that could be on the way up or it could be on the way down. And therefore, from there to there is 70.56 meters, or to this position is 117.6 meters. So therefore the distance between these two walls is going to be the difference between those. So therefore we say, hence, distance from first wall is either going to be 70.56 minus 47.04 meters, which gives us 23.52 meters, or we have 117.6 meters minus 47.04 meters, which gives us 70.56 meters. And if we go back to the start of the question, it says, show that the second wall must not be less than 23.52 meters and not more than 70.56 meters from the first wall. So we would just conclude with that in our answer. So, end of question. Okay,